Hi students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter of physics called as measurements. Okay, now let's see this. First, what do we understand by order of magnitude? What do we understand by order of magnitude? Now, order of magnitude is the order of magnitude of a number is defined as the power of 10 which is nearest to that number. Order of magnitude of a number is defined as the power of 10 which is nearest to that number. Right? For example, if I have velocity of light. Now if I consider the velocity of light velocity of light is 3 into 10 raised to 8 meters per second. Right? In that case, the order of magnitude of velocity of light is 10 to the power of 8. The power, how do I define it? It is defined as the power of 10 which is nearest to that number. So the power of 10 which is nearest to that number is 10 to the power of 8. So my order of magnitude is going to be, the order of magnitude of the velocity of light is going to be 10 to the power of 8. Right? Similarly, if I consider another example, let us consider an example, charge on electron. Charge on electron is 1.6 into 10 raised to minus 19 coulombs. Right? If this is the charge on electron, then order of magnitude will be 10 to the power of minus 19. Fine, do we get this thing here? So, thus the order of magnitude is defined as the power of 10 which is nearest to the number. Right? The positive index of 10 indicates that it is the given quantity is very large. Like here in this case, this is a positive power of 10, so it indicates that the given quantity is very large. Negative power of 10 indicates that the quantity is very, very small. Right? So do we understand what is order of magnitude? Next, let's consider the next thing that you have is mistake. What do we understand by mistake? Mistakes are faults caused by carelessness of an untrained experimenter. Right? If you are not very well trained in an experiment, while doing the experiment you may be careless and you may not do the experiment correctly, and that is called as mistake. So what are mistakes? Mistakes are faults caused by the carelessness of an untrained experimenter. That's what is a mistake, right? Thus, mistakes can be avoided by careful and properly trained experimenter. Right? These are mistakes can be avoided by careful and trained experimenter. Fine, do we get this thing clear? Now, what are the reasons for mistakes? Reasons. Why do we have mistake? Or what are the causes of mistake? One, lack of skill. You don't know how to do the experiment correctly. Right? Second, faulty observations. You are not recording your readings correctly. Right? Third, wrong reading. You've read it correctly from the instrument, but you're writing it wrongly in your book. Wrong reading. And the last is incorrect mathematical operation. You're not doing it correctly. You're not performing your calculations correctly. Right? So these are the reasons which cause a mistake. So mistakes can be avoided if you are skillful, if you take correct observations, if you take correct reading and you do correct mathematical operations. Right? So these are mistakes. Next, what are errors? Right? Errors are the shortcomings which can occur even to the most careful observation. Right? Errors cannot be completely eliminated but can only be minimized. Right? Errors are something that is caused due to the shortcoming of the instrument. If you want to measure a very small thing, and instead of using a vernier caliper, if you use a meter scale, obviously you will get a wrong reading. Not because you have made a mistake, because that instrument is incapable of measuring that particular data. Right? So errors are shortcomings which cannot be completely eliminated but can be minimized. Fine, do we get this thing clear? So what are errors? Errors represent the possible variations of the measured value from the actual value of the physical quantity. The uncertainty produced or variation can occur in the measurement, right? Because of errors. So when we talk about errors, these are certain shortcomings of the instruments owing to which you cannot get correct reading. Fine, do we get this thing here? So do we understand what are errors? Now when we talk about what are errors, shortcomings of the instrument used for measurement. Right? So these are what are errors. Right? Now, when we talk about errors, how do I eliminate errors? Right? In order to eliminate errors, you have different things. You have to, when we talk about errors, and in order to eliminate errors, you have to take large number of observations. So when you are in the lab, you will always see that the teacher will tell you to do the experiment 3 times or 4 times, so that you can eliminate those errors. Right? Do we get this in here? So in that case, what do you mean by an average value? What is average value? Average value is nothing but when you are taking an observation, it is the average of all the values. So it is all the observations divided by the total number of observations. That means average value will be all the observations, that's A1, A2 plus A3 up till AN divided by the number of observations. Fine, do we get this thing here? Next, absolute error. What do we understand by absolute error? It is nothing but the difference between the average value and the measured value. Right? It is defined as the difference between average value and measured value. So thus I can say that absolute error is written as delta, is average value minus the measured value. Right? Next, what do we understand by average absolute error? Average absolute error. Average absolute error is the average of all the absolute errors. It is the average of all absolute errors. right? Then absolute average error is nothing but absolute error 1 plus absolute error 2 plus absolute error n divided by the number of observations. This is my average absolute error. Next, what do we understand by relative error? What is relative error? Relative error is the ratio of average absolute error to the average value. It is nothing but the ratio of average absolute error to average value. Right? So that means I can say that relative error is nothing but average absolute error upon average value. Right? Next, what is percentage error? Right? Percentage error is nothing but relative error multiplied by 100. It is nothing but relative error into 100. Right? So it is expressed as a percentage of the relative error. So when relative error is expressed in terms of percentage, that is called as percentage error. Right? Do we get this thing here? So I can therefore say that delta A is delta AM upon AM into 100. These are all the different kinds of errors that you can have. Fine, do we get this thing here? Now let us see numericals based on this. Take out the first numerical, please. The diameter of a wire, is measured by a micrometer screw gauge. The diameter of a wire is measured by a micrometer screw gauge and is found to be 1.75 millimeters. The diameter of a wire is measured by a micrometer screw gauge and is found to be 1.75 millimeters. The least count of the micrometer screw gauge, is 0.001 centimeters. Find the percentage error in the measurement. Find the percentage error in measurement. Okay. Now since the least count is given to you in centimeters, I have to convert the diameter also into centimeters. So I can say diameter is 1.75 millimeter. To convert from millimeter to centimeter, you multiply by 10 raised to minus 1. So this will be 1.75 into 10 raised to minus 1 centimeter. That's how you convert from millimeters to centimeter. Now what does least count indicate? It indicates the smallest measurement that can be accurately made by the instrument. Right? Any measurement which is less than that cannot be accurately made by the instrument. So the absolute error that the instrument can make is going to be its least count. Any measurement less than that cannot be accurately measured. So the absolute error is going to be 0.001 centimeters. Right? The measurement that I am making is 1.75 into 10 raised to minus 1. So that will be 0.175 centimeters. Once I have this, I can find out percentage error. Percentage error is absolute error upon the given measurement into 100. 0.001 upon 0.175 into 100. Right? When you calculate this, this will come to 0.57%. So there is a 0.57% error in the measurement of the diameter. Right? Take out next one, please. the volume of a solid sphere, the volume of a solid sphere of length 10 centimeters and radius 4 centimeters, the volume of a solid sphere of length 10 centimeters and radius 4 centimeters is measured by using a vernier caliper. Is measured by using a vernier caliper whose least count is 0.01 centimeters. Find the percentage error in the measurement. Find the percentage error in the measurement. Find the percentage error in the measurement. Okay. Now, they have asked you the volume of a solid sphere. Now, first of all, let's find out what is volume. Volume of a sphere, guys, is pi r square L. Right? Now, since the least count is 0.01 centimeters, least count represents the error that will be there. What are the two things I'm measuring? I'm measuring length and radius. Both are being measured with the help of the vernier caliper. So therefore, the error in the radius will be 0.01 centimeters. Right? So your delta R will be 0.01 centimeter and delta L will also be 0.01 centimeters. Right? Now, I can say that percentage error in volume. Percentage error in volume is error in volume upon volume into 100. Right? Now, if I'm going to be measuring the volume, what are the various things that I'm going to be measuring? Volume, guys, we've said is r square L. That means I'll be measuring the radius twice and the length once. Every time I measure the radius, there is going to be an error because of the limitation of the instrument. Right? Therefore, I can say that this can be written as, I'm going to measure the radius twice, so 2, right? Error in radius upon radius. That will give you the total error that I will get when I measure the radius twice. Plus, I'm going to measure length, right? So, length is going to be error in length upon length. To convert this into percentage will be into 100. So this is going to be 2 into 0.01 upon radius is 4 plus 0.01 upon 10 into 100. I've just substituted the values. So this, when you solve, will give you 2 upon 4 plus 1 upon 10, that's 0.01, I took it outside, multiply by 100, will give you 1. So this is 2 upon 4 plus 1 upon 10, which is nothing but 1 upon 2 plus 1 upon 10. 10 is the common denominator, 5 plus 1, 6 upon 10, so that is 0.6%, right? So the answer is going to be 0.6%. So there is going to be a 0.6% error in the measurement of volume. Fine? Right, let's see the next one, guys. We take down the next one. The radius of a sphere, is measured. The radius of a sphere is measured and is found to be 4.68 and is found to be 4.68 plus minus 0.01 centimeters. 4.68 plus minus 0.01 centimeters. Find the percentage error in the measurement of volume. Find the percentage error in the measurement of volume. Find the percentage error in the measurement of volume. Right? Now, they've given you radius is 4.68 centimeters. Plus minus indicates the error in radius. Error is 0.01 centimeters. I want to find out the error in the measurement of volume. Volume of sphere is 4 by 3 pi r cube. Right? Now, once I know the formula for volume, I can therefore find out percentage error in volume is error in volume upon volume into 100. Now, if I am measuring the volume, 4 by 3 is constant, pi is constant, r cube. That means I will be measuring the radius 3 times. First I will measure r, then again r, and then again r, because that's how I get r cube. So I am measuring radius thrice. I will get an error in the radius thrice. So that will be delta r upon r into 100. That's the only one quantity that I will be measuring. Right? So this will be 3 into delta r 0.01 upon r 4.68 into 100. 0.01 into 100 is 1. So this will become 3 upon 4.68. Right? So when you divide this, this will give you 0.64%. So the error in the measurement of volume will be 0.64%. Next, take on next one please. An experiment is conducted to find the acceleration due to gravity. An experiment is conducted to find the acceleration due to gravity. The following values are obtained. The following values are obtained. 989.5 centimeters per second square, 984.7 centimeters per second square, 977.7 centimeters per second square, 976.5 centimeters per second square, and 982.4 centimeters per second square. Find the relative and the percentage error in the measurement. Find the relative and percentage error in the measurement. Find the relative and percentage error. Find the relative and the percentage error in the measurement. Right? Now, first let's find out the average value. We will call the average value as say G. Average value is going to be nothing but G1 plus G2 plus G3 plus G4 plus G5 upon 5. Add all the values of G and divide by 5. When you do this, guys, you can do this and get the answer. You should get the answer for this as 982.1 centimeters per second square. So that is going to be my average value of G. Now, let us find out the absolute error. Absolute error is nothing but average value. It's the difference between the average value and the given value. So, absolute error of G1 modulus will be nothing but G minus G1 modulus. So, G minus G1. G is nothing but 982 989.1 minus G1 989.5 modulus. Now, irrespective of whether the answer is positive or negative, you got to write the answer as positive. Like in this case, the answer is negative 7.4 modulus, which will be 7.4. I have shown you how to find out one absolute. The remaining I'll give you the answer. You should be able to find out. So I can now say that absolute error in G2. Same way I just explained to you how to do it. You can do it and get this answer. Is going to be 2.6. Absolute error in G3 is going to be 4.4. Absolute error in G4 is 5.6. Absolute error in G5 is 0.3. So thus you have absolute errors, right? Next, let's find out the average absolute error. Average absolute error is the sum of all the absolute errors divided by the number of terms. So absolute error in G1 plus absolute error in G2 plus absolute error in G3 plus absolute error in G4 plus absolute error in G5 divided by the number of terms. There are 5 terms, right? So when you add subtract this, you will get the answer as 4.06 centimeters per second square. So the average absolute error is 4.06 centimeters per second square. Once you have this, then you can find out relative error. Relative error is average absolute error divided by the average value. Average absolute error is 4.06 divided by average value. Average value you found out is 982.1. So when you divide this, you will get the answer as 0.00413. Yeah, 0.0413. No units because this is a ratio. Once you have this, then you can find out percentage error. Percentage error is nothing but relative error into 100. So that's 0.00413 into 100. That's 0.413%. Right? So that is going to be my percentage error in the measurement of G. Right? Next, let's see another sum, guys. The time period of a simple pendulum, is given by the formula. The time period of a simple pendulum is given by the formula T is equal to 2 pi root of L by G, where L is the length of the pendulum and G is the acceleration due to gravity. Verify this formula dimensionally. Verify this formula dimensionally. Now the formula will be dimensionally correct if I have the same dimensions on the left hand side and the right hand side of the equation. Now first let's find out the dimensions of T. Dimension of T will be M0, L0, T1 Then I can find out the dimensions of L, which will be m0, L1, T0, mass, length and time. Next, G. Gravitation is nothing but the units of gravitation. SI units of G is meters per second square. If this is the units of G, then the dimensions of G will be m0, L1, T minus 2. There is no mass here, right? So in that case, meters. So you are measuring the length once and time is in the denominator. Now, 2 pi we know is a constant. So let us find out the dimension of RHS. On the RHS you have 2 pi root of L by G, right? Now in that case, if I substitute this, I will get 2 pi is a constant. This is root of L. L is going to be m0, L1, T0. G is going to be m0, L1, T minus 2. Right? So in that case, you will get this as laws of indices. If I apply laws of indices, this will become m0, L0, T2. Square root of T2 will be T1, which will be m0, L0, T1. But m0, L0, T1 is the dimension of T, which is nothing but dimension of T. Therefore, I can say that since the dimensions of LHS and RHS are same, therefore the equation is dimensionally correct. That's how you prove that an equation is dimensionally correct. Fine, do we get this in here? So this finishes the numericals of measurements. We will stop this here for the day. Thank you very much.